So those aluminum conducting electricity doesn't change aluminum. Gasoline being combusted does change it into something else. It gives off heat and light. Evaporates is a process of changing from a liquid to a gas. So that's just a change of state. Gold has a high density. It just tells you how compact it is. Carbon is brittle. That just means it can break apart easily. And then if it sinks in alcohol, it just says that it has a higher density than alcohol. Then it just sinks down. But they don't. There's nothing that really changes when that happens. Oh, I got two more I didn't see. Grease catches on fire. That should give you an idea that it is chemical because it's flammable. And it will change and it will heat up. And then soluble means it dissolves or mixes, and so that's physical. Okay, questions on those? Okay, you guys have your reviews out, looking at them? Okay, you got your review out? Get your review out so you can see how you're doing on them. Okay. Wood burned, chemical. Water condensed, that means it's going from a gas to a liquid. So that would be physical. Ammonia evaporated, which means it's going from a liquid to a gas. So that's physical. Balloon popped, it's just separating the gas from the balloon. So that's just a separation process, that's physical. The oil and the water separated in the mixture. Oh, I'm sorry. The banana ripened overnight. You have a different smell. It changes color, right? Banana. So that would be chemical. Sodium reacted with water to produce hydrogen gas. You haven't passed, Emma. Okay, you need to make sure you get here so you don't get counted for absent after 10 minutes, okay? You got your review? Okay, sodium reacted with water to produce hydrogen gas. That's chemical. And then the oil and water separated in the mixture. They just separate. It's just a separation process. That would be physical. Okay, so the wood burn, chemical. We know it's giving off heat. Water condensing is just changing the state from gas to liquid. Ammonia evaporating. Going from a liquid to a gas, that's a physical change, change of state. Balloon popped, it just separated. Ripening means it's chemically changing inside. Reacted, right there, reacted. And it produces gas, bubbles, chemical. And then the oil and the water separated, that's physical. Questions on that you guys have? How'd you guys do? Do you have your review?
No.
Do you need to have it maybe out so you can kind of follow things?
Oh, how long?
Did you not have your stuff with you or what? Looks like that. So look for that. Okay. So on the test, they'll just be really simple, one word answers on those, just like that. Won't be much different than that. Okay. We get to the thing where we've got to decide if it's element or a compound. All right? So an element or a compound. So if you see two capital letters next to one another, that's a compound. There are two capitals. One stands for nitrogen, and the other one stands for oxygen. So you're combining those two together to make a compound. OH, two capital letters side by side. It's a compound. We've got three different elements here. We've got calcium, carbon, and oxygen, so that's a compound. Bromine, you only have one element there. So that's an element. You only have one there, it's just combined to itself, so it's still an element. Nickel's an element, sodium's an element, you can tell because the first one's uppercase, the second one's lowercase, and then this one's a compound because it's got two capital letters next to one another. Question? if you would draw these out, I think I did this one for you. You'd have carbon, and then you'd have hydrogen. Try to separate these on the outside out a little bit further from one another. So that would be a compound of CH3Cl. This would be what we would have if we try to do nitrogen. It would look like that. N2 would be two of these side by side bonded. And then Cu would just be by itself. We could go ahead and have a bunch of Cus stuck together. Usually where you're going to have one, you're going to have a bunch of C's. So you can, or you could draw one. No big deal on that one. Questions on that? Okay.
On C.
Yes.
If there's like two of the same, do you always draw them the same size?
Yes. Yeah, and I try to draw them the same size, but if you put a letter in there, I'll know that they're the same element. So not everybody's perfect drawing those out the same size perfectly. So yeah, you can just I just put the letter in. Some people like to do a key with it, but I don't think there's a reason to do the key. Okay. Next one. There, I think at the bottom, I don't think I have that one copied out. So on number 5, we have 1, 2, 3, 4. You're just going to have to identify these, and I'll just do one of them instead of how many's drawn in there. Okay, so which represents an element there? So which ones represent elements? So we got 1, 2, 3, 4. Which ones? 3 does for sure.
Does 4?
4 does, because those are elements. They're just a mixture of elements. It's asking which one represents elements. And 2 also represents elements. Because it's the same one. They're the same ones hooked together. So they'd have to be 2 different ones hooked together if they don't. B, which one represents compounds? You only got 1. Number 1. And then which one represents molecules? You only have 1.
2.
Well, I guess you do. You have 2 of them, I guess. I'm sorry. 1 and 2. 1 and 2 would be molecules. Anything that it's got linked together, multiple atoms, would be a molecule. So it would be 1 and 2. Okay, this is one that we haven't practiced much on, and I just thought I'd have you try it. And they're really easy. So on this one, it's supposed to name the elements and then list how many you have. So what's the elements in this first one? Hydrogen. Sulfur. And oxygen. How many do we have of each one of those?
2 hydrogen, 4 oxygen, 1 sulfur.
Yeah, 2 hydrogens, 1 sulfur, and 4 oxygens. So whatever's behind it tells you how many you have. So that subscript of 2 tells you have 2 hydrogens. There's nothing behind the sulfur, so that means you have 1 of it. And then there's 4 behind oxygen, which means you got 4 of them. So it's just looking at subscripts. Next one, ammonia.
Hydrogen and nitrogen.
Yep, hydrogen and nitrogen, and then you have 1 hydrogen and 3 nitrogens.
Yeah.
So you have 3 hydrogens and 1 nitrogen. Okay, yesterday, if you were gone, what we did is we went over difference between metals and nonmetals and gave characteristics of those based upon the lab we did. So this would be a metal, and this would be a nonmetal. This would be a metal, This would be a non-metal, and this would be a metal. Okay. So metals have a luster. They react with acids. They break apart easily, which means they're brittle. And then, I'm sorry, non-metals do that. Non-metals don't react with acids, where metal conducts electricity. So that's what you'd have for those. Okay? All right. So, when we look on the periodic table, you guys get your periodic table because you're going to have to use it later today. So, go ahead and get that out. Based upon its location, we have different areas of the periodic table that we can emphasize. And if you remember, we gave circles, and the circles that we gave was kind of this area here was 1. We had this area right in between here would be 1, and then we had an area here was 1. So, first of all, we're going to take a look at is calcium. Calcium is located right here. So that's a metal. Okay. Next one we have is bromine. Bromine is located right here. So that would be a non-metal. That's metal. That'd be a non-metal. Silicon's right here. So that's a metalloid. There's silicon. So that's a metalloid. Neon is located right here. What would that be? Non-metal. And then iron's located right here. That's a metal. Okay, so if it's in this region, tomorrow if you got your periodic table, if it's in this region, it's a metal. If it's in this region, it's a non-metal. And if it's in this region, it's a metalloid. What's a good conductor, malleable and shiny?
Metal.
What's a fair conductor but brittle?
Metalloid.
Metalloid. And a poor conductor?
Non-metal.
Non-metal. Okay. So, hit those again. If you do these, you'll use your book. So this first one is 0.045 grams. Then you would have grams here, and up here you have milligrams. And you say for every 1 milligram, you got 0.001 grams, and you get an answer out that's 45. Next one, you have 350.5 liters. You would say for every you have 1,000 liters for every 1 kiloliter. So the answer would be 0.3505. And then the last one, you got 200 pounds. And then you would say for every 1 kilogram, you have 2.2 pounds. Some of you might have set it up to say for every 0.45 kilograms, you have a pound. You get the same answer out for that. Okay? 90, yep. Okay, so those would be that simple. Okay, and then you have the backside, and I'll just go through the definitions, what you're supposed to have written in there.
There's one more.
Oh, is there one more?
Yes.
Okay. The 100 meters to feet, I think, and I'll just give you the answer for that one. Would the answer be about like,
I got 320.
let me see here. 270? Is that what you guys got?
I got 328.
Is it 328? Okay, I'm not, the conversion on that would be 100 meters, and then you go meters to feet,
Yeah.
and is it the 3.28
3.28.
for every
1 meter.
1 meter? So, yeah, 328. Okay. All right, now we'll go to the back.